Hi everyone, welcome to the second half of this section on rational exponents. And now what I want to do is show you how you can simplify these things, and I'm going to tell you that all of the rules that we learned about how to deal with exponents, even when exponents were just numbers, regular integers, those same exact rules apply even if the exponents are rational or are fractions. The same type of properties that we did when they were whole numbers do the same thing when they're fractions. Let me walk through them just to remind you what they are. Okay, the first property involves when we multiply numbers with exponents if the bases are the same. So I'm multiplying two numbers with the same base. For instance, a to one power times a to the other power, we learned that we would just add the exponents. You do the same thing even when the exponents are fractions. So 8 to the 1/3 times 8 to the 2/3, since it's the same base, it's just 1/3 plus 2/3, which is 1, and so this simplifies to be 8. We learned before that when you have a power of a power, so I have a to the power of m, and that's raised to a power, powers of a power is you multiply the exponents, see, m times n. You do the same thing even if they're fractions. For instance, I have 5 to the power of 1/2, and I'm raising that to the power of 4. So it's 1/2 times 4, which is 4/2 or 2. So that would be 5 squared. The final answer of this one would be 25. We also learned that when you have something in parentheses raised to a power, everything in the parentheses gets raised to that power. So I have AB raised to the power of m. That means A is raised to the power of m and B is raised to the power of m. So here it is with numbers, but the same would apply to variables. I have 4 times 5 to the power of 1/2. That means it's 4 to the power of 1/2 and 5 to the power of 1/2. 4 to the power of 1/2, remember that's the same as the square root. Square root of 4 is 2, so that becomes 2 times 5 to the power of 1/2. Remember that when we have a negative exponent, the negative exponent is saying, help, help, I'm on the wrong side of the fraction bar, right? You need to invert it. So a to the power of negative m is the same as 1 over a to the power of m, and then the negative disappears. In a number, like if I have 9 to the power of negative 1/2, that means 1 over 9 to the power of 1/2. 9 to the power of 1/2 is 3, so this is 1/3. If I have the same base and I have a to one power over a to another, I subtract. It's m minus n, right? M minus n. Same thing with fractions. For instance, if I have 7 to the power of 3 over 2 over 7 to the power of 1/2, notice my bases are the same. That's why I can do this. Then it's 3/2 minus 1/2, or 2/2. So this is 7 to the power of 2/2, which is 1. That's just to 7. So the same things we did with whole numbers, we do with fractions. And the last one, again, is if we have a fraction in parentheses raised to a certain power, then that means it affects both the numerator and the denominator. Both the numerator and the denominator are raised to that power because it's in parentheses. So if, for instance, if I have the fraction 5 over 27 and it's raised to the power of 1/3, this power affects both the 5 and the 27. They're both raised to the power of 1/3, which is nice because the third root of 27 is 3, so this becomes 5 to the 1/3 over 3. So those same properties, this is a review, those same properties we did before, they work here as well. So that means we're going to start simplifying these things. So here's a problem, and you're asked to simplify this. And it's kind of hard because this is a 4th root and this is an 8th root, so it looks complicated. But notice both of them have the same radicand. They're both dealing with x. So since they both have that same variable, let's try to simplify it by changing this from radical form to exponential form. So this x, 4th root of x cubed, becomes x to the power of, remember this is the power over the root, 3 over 4. So my numerator is x to the power of 3/4. My denominator has a power of 2 and a root of 8, so it's x to the power of 2 over 8. I can totally simplify that. 2 over 8 is the same as 1/4. Now, since I have the same base, I have 3/4 over 1/4, I can subtract, right? So what's 3/4 minus 1/4? That's 2/4 or 1/2. 2/4 is 1/2. So this is x to the power of 1/2. And remember, 1/2 means the square root. So my final answer is the square root of x. That looks a whole lot simpler than that. Okay, now I'm asked, what's the product of this in simplest form? So I want to multiply these, but they are different indexes. This is fourth root, this is second root. So what I'm going to do then is change them to rational exponents so that I can multiply them. So the square root of 3 is 3 to the power of 1/2, and the fourth root of 3 is 3 to the power of 1/4. Now, since I have the same base and I'm multiplying, I can just add those exponents. 1/2 plus 1/4 is 3/4. So this is 3 to the power of 3/4. So I have the fourth root of 3 to the power of 3. The fourth root of 3 to the power of 3. Well, 3 to the power of 3 is 27. So what I have then is the fourth root of 27, and that's my simplest form. Another one, this one involving division instead of multiplication. I have the square root of x cubed and the cube root of x squared divided by the cube root of x squared. I want to simplify this. Okay, let's simplify this one by changing it to exponential. This 3 is the power, 2 is the root. So this is x to the power of 3 over 2. This one, 2 is the power, 3 is the root. So this is x to the power of 2/3. Now what I have, since I have the same base, it's 3 over 2 minus 2 over 3. So I'm going to change those to sixths. And this is 9 over 6 minus 4 over 6. And I end up with x to the power of 5 over 6. I can combine them like that. Now remember, the numerator is the power. The denominator is the root. So I'm going to write my answer as the sixth root of x to the power of 5. And I have divided this. Here's a similar issue. I want to multiply the square root of 7 times the cube root of 7. I've got the same base of 7, but because the indexes are different, I would think I can't multiply. But if I change them to exponential form, then I can. So this is 7 to the power of 1/2, and this is 7 to the power of 1/3. So now, in order to multiply them, I add 1/2 plus 1/3. And 1/2 is 3/6, and 1/3 is 2/6, so I come up with 7 to the power of 5/6. So I have the sixth root, remember this is the root, of 7 to the power of 5. But 7 to the power of 5 is a number. You can find it on your calculator. It is 16,807. And that's your final answer. Okay, another thing we're going to use these properties to do is simplify some of these expressions. For instance, how could I simplify 16 to the power of negative 2.5? So first of all, I would change the decimal to a fraction. Negative 2.5 is the same as 5 over 2, so this becomes 16 to the power of negative 5 over 2. Now we know a negative exponent means I need to invert it, put it on the other side of my fraction bar, so this becomes 1 over 16 to the power of 5 over 2. Now let me show you how this works. This denominator is the root, isn't it? A 2 means a square root. What's the square root of 16? The square root of 16 is 4. So I can simplify that by going 4 to the power of 5. I don't know if I explained that in a way that's going to be really, really helpful. Let me show you another way to think about it. This is 1/2 times 5, right? The square root of 16 is 4. So 4 to the power of 5. Anyway, you can do that. Take that root of that number. If you can take that root of that number, do it. That gets rid of this denominator, and now I'm just left with whatever that root was. In this case, it was 4 to the power of 5. So 4 to the power of 5, I think, is 1,024. 1 over 1024. This problem you can do in the similar, very same way. This is the base of negative 32. It's raised to the power of 4/5. So I'm seeing that fifth root. This means the fifth root of negative 32 to the power of 4. So when you think twos, 2, 4, 8, 16, 32, sure enough, the fifth root of negative 32 is negative 2. So this is the same as negative 2 to the power of 4. So negative 2 to the power of 4, 2, 4, 8, 16. It's positive 16. Same way, 32 to the power of negative 3/5. First, we're going to invert that to get rid of this negative exponent. It's 1 over 32 to the power of 3/5. Is there a fifth root of 32? We just did that. In this case, it's positive 2. So this is 2 to the power of 3. So this is 1 over 8, because 2 to the power of 3, 2, 4, 8. There we go. It's 1/8. Another problem, very similar. I have 16 to the power of 3/4. Start with this root. Can you take the fourth root of 16? 2, 4, 8, 16. Sure enough, it's 2. So the fourth root of 16 is 2. So take 2 to the power of 3. 2, 4, 8. It is 8. Here's 9 to the power of negative 3.5. So we've got the negative to deal with. We have the decimal to deal with. So 3.5, 3.5, that's 7 over 2. So first of all, that's 9 to the power of negative 7 over 2. Let's flip that to get rid of the negative. 1 over 9 to the power of 7 over 2. There we go. Now this 2 is a square root. Is there a square root of 9? There is. So this is the same as 1 over 3 to the power of 7. So 3 to the power of 7 is a big number that I don't have memorized. It's 2,187. So our final answer is 1 over 2187. Okay, now we are asked to write full expressions in their simplest form. Now we've got some variables mixed in. How are we going to deal with this now? So let's walk through a couple of these one at a time. I have this expression, negative 8x square root of xy, and I'm taking that entire expression and raising it to the power of 2/3. How do I simplify that? Step 1 is to remember everything in the parentheses gets raised to the power of 2/3. So start by doing that. I have negative 8 to the power of 2/3. I have x to the power of 2/3. And I have the square root of xy to the power of 2/3, right? Xy is, or it means square root is 1/2, isn't it? So what I have then is xy, x to the 1/2 and y to the 1/2, both of those to the 1/2 raised to the power of 2/3. Okay? Makes sense? All right, now go through and simplify a power of a power. So I'm going to rewrite and do that. Negative 8 to the power of 2/3, x to the power of 2/3. 1/2 times 2/3 is 2/6. 2/6 is 1/3. So this is x to the power of 1/3 and y to the power of 1/3. Do you see how 1/2 times 2/3? 2/6, which is the same as 1/3. Now I can take each part and combine where I can. The cube root of negative 8 is negative 2, and negative 2 squared is 4. So this is 4. I have x to the 2/3 times x to the 1/3, same base. I can add my exponents. 2/3 plus 1/3 is 1. So I have x to the power of 1. and I'm left with y to the power of 1/3. If I can leave it in exponential form, it would look like that. If it's in radical form, it would look like 4x and in the cube root of y, like that. Exponential form, radical form, same expression. Here's another problem we've been asked to simplify. I have the expression 16y to the negative 8, and that entire expression raised to the power of negative 3/4. So everything in the parentheses gets raised to this power, so let's do like we did before. 16 gets raised to the power of negative 3/4, and my y, I have a power of a power, so I'm going to multiply. What is negative 8 times negative 3/4? It's positive 6. So now I have y to the power of 6. Now I'm going to keep going because I have a negative exponent. Don't want a negative exponent. I need to bring that down below. This exponent is not negative. It stays above in my numerator. This moves down, is inverted to below. So I have y to the 6th over 16 to the power of 3/4. Now it's a bit positive because it's on the right side of the fraction bar. Now look, is there a 4th root of 16? Check your 2's. 2, 4, 8, 16. Sure enough, the 4th root of 16 is 2. 2 to the power of 3, 2, 4 is 8. So I have y to the 6th over 8. And I'm done. I'm going to do one more that's a little complicated, and then I'm going to close out with your lesson check, which is one of these for you to do to bring into class, and then we'll be done. But these are complicated. I think the more you see it, the easier it is. So I have this expression, all of it, the entire parentheses, raised to the power of 3/2. I think I'm going to start by changing this to exponential form because I find that easier. So this becomes 9x, and this is y to the power of 1/4. And all of that is raised to 3/2. That's just a little easier for me to deal with than this radical form. And now I'm going to multiply everything, or raise everything to the power of 3/2. 9 to the power of 3/2, I'll just write what I'm doing. X to the power of 3/2, and y to the power of 3/8. 1/4 times 3/2 is 3/8. Okay, take one at a time. This is a square root, and there is a square root of 9. It's 3. So the square root of 9 is 3, and 3 raised to the power of 3 is 27. So this number becomes 27. And that part's easy. Now I'm going to show you what we're going to do with this. I want to make these two denominators the same so that I can write it as one radical. So this is 3/8. I can change this x to 8ths as well. So 3/2, changing that to 8 is 12/8. So this becomes 12/8. Now I told you I was doing the complicated one. I have 12/8. I'm going to split this because that's 8/8 plus 4/8, isn't it? So I have x of 8/8 and times x of 4/8 to get this. And the reason I did that is because I've got 1x here. So I can pull out 1x, and that leaves x to the 4/8 and x and y to the 3/8. So since my root is 8, I'm going to take the 8th root of x to the power of 4 and y to the power of 3, and whoa. Whew, that's my final answer. That was kind of gnarly. Okay, I'm leaving you with your lesson check. It's not nearly as complicated as the last one, but you still have some things to deal with. 8x to the 15th raised to the power of negative 1/3. So bring that in tomorrow. We'll see how you do. And that will be it for this section. You can see quickly, really clearly why I split this into 2 days. Bye for now.